Thank you very much. Thank you. And thank you. Good evening. Bob Hawke and Andrew Peacock have been outdoing themselves this past week to see who can give us the greenest environment policy. I mean, Bob Hawke's statement the other day was even touted as the most comprehensive in the world. But neither of them has tackled the really hard issue of what to do about all the coal-burning power stations that generate most of our electricity in Australia. They're responsible for at least half the emissions of carbon dioxide into the atmosphere. Just to give you some idea of what's involved, they burn 3 tonnes of coal to generate enough electricity for 1 person in a year. 3 tonnes. But that 3 tonnes results in 5 tonnes of carbon dioxide. So, I mean, you can see it's an environmental disaster. But what's the alternative? Well, a number of people in the power industry, senior, respectable people, they're saying that it's inevitable now that we have to go nuclear because it's clean. And even some environmentalists are having second thoughts. That's certainly the way they've gone in France. 70% of their electricity there is generated from nuclear power stations. In Britain, Margaret Thatcher is pressing on with the nuclear power program because she says it's clean. And in Australia, Bob Hawke's gone so far as to tell opponents of nuclear power that they might have to reconsider their prejudices in the interests of the environment. But Dr. Bill KEEPIN is in Australia on a lecture tour saying no, no, no to all of that. Dr. KEEPIN is a research scholar at the Rocky Mountains Institute in Colorado and a former energy coordinator at the United Nations Environment Program. Good to have you with us, Dr. KEEPIN.
Thank you.
I thought perhaps you should, first up, just hear some of the arguments we're getting to support nuclear power in Australia.
Okay.
They might change your mind.
Okay.
But Peter McGauran, you're Shadow Minister for Science and Energy. You're having a second look at this, aren't you?
Very much so. Up until now, it's quite true, as you say, that the debate has been polarised throughout the world regarding nuclear power. But the starting point is that nuclear power is clean, environmentally clean. And I envisage, like so many others, an energy mix where you have a gas, coal, together with nuclear power, together with more efficient use of energy and a reduction in the dependence of coal. So that way you get a balance between correct and legitimate environmental concerns and our future energy needs.
So you're saying, look, let's not just reject nuclear power as a sort of an emotional knee-jerk. Let's look at it logically.
Absolutely. It simply has to be an option.
Derek Hampson from the Uranium Information Centre. You've been pushing the nuclear power argument for a long time, haven't you? On what grounds specifically?
Mainly that it's one of the cleanest forms of producing baseload electricity. There are now, following on what Peter was saying, there are now over 400 nuclear reactors operating in the world today. They're producing 1/8 of the world's electricity. So clearly some 25, 26 countries have looked at this and have come to the conclusion that it needs to be at least part of their energy mix.
But how do you reconcile the hazards? I mean, we can't go on pumping carbon dioxide into the atmosphere from these coal-burning stations we've got. But what about the hazards of nuclear?
The coal-fired stations at the moment are putting something like 2,000 million tonnes of carbon dioxide into the air each year. Nuclear is saving that going in. That's the amount that's being saved by the 16%, the 1/8 of nuclear electricity. To put that another way, nuclear electricity produces radioactive waste. If you, Peter, got all your electricity to a ripe old 75,
right,
you would be responsible for about that amount of high-level radioactive waste. If you get all your electricity from coal, you'll be responsible for something of the order of 750 tonnes of carbon dioxide into the atmosphere, 250 to 300 kilos of other heavy metals and materials, including things like cadmium, selenium, some radioactive materials because coal is radioactive, mercury, vapours like chlorine, materials which stay permanently in the atmosphere.
So without question, nuclear is by far the cleanest alternative.
Absolutely.
I mean, if we're not talking about solar and wind and so on.
If you look at it from the point of view of per unit, per 1,000 megawatts, let's say, of electricity produced in baseload stations, then nuclear has by far and away the best record so far.
All right, Bill KEEPIN, are you persuaded?
Well, the point is that even if we went for nuclear in a big way, it would not solve the global warming problem. A lot of people have assumed that because fossil fuels produce carbon dioxide, then the solution to global warming will be nuclear power. But it turns out that an analysis shows that won't work. First of all, if in the absence of substantial efficiency improvement in the future, it turns out that that future energy growth will be moderate to high. And so you can do an analysis where you show if you replace all coal worldwide with nuclear power, and that's a rather extreme assumption, by the year 2025, that's the first assumption. And second, if nuclear power can be obtained very cheaply, and I'm talking now 5 cents per kilowatt hour, which is the nuclear dream in the United States, and thirdly, if the plants can be built very quickly, and I'm talking 6 years now for a large 1,000-megawatt station, such as they have achieved in France, and finally, if you ignore all of the major problems associated with nuclear power, I'm including nuclear waste treatment and storage, safety issues, environmental issues, decommissioning, and the possible proliferation of nuclear weapons, and all of those problems, then it turns out you would have to build a nuclear plant every day and a half in the high case, or every 2.5 days for nearly 4 decades, just to replace the coal. Moreover, even if you did that, it turns out that due to the oil and natural gas that's anticipated in future energy growth, you would still have carbon dioxide emission levels remaining at or above today's levels for all future time.
Well, Don Stewart, you've been pretty close to this. You're former chief executive of
several absolute basic fallacies in that. If you didn't replace the coal with nuclear, you would be 4 times as much CO2 to atmosphere. Second, nobody in their right mind has ever said that nuclear should replace all coal. Nobody in their right mind has ever said that. They've said that nuclear has got a major part to play. As to nuclear costs, in Japan, the full detailed MITI reports, in Germany, the full detailed reports that come out of there, in France, the full reports, show that nuclear electricity is the lowest cost of all electrical generation in those countries, bar none. And that includes the provision in the nuclear costs, provision in reserves for decommissioning, for fuel reprocessing, and for waste disposal as charges against their electricity costs, which they all do. And you talk about a build period of 6 years, for goodness sake. They've been building nuclear power plants in Japan for 4.5 years since, as long as I've known them. And in Germany, the standard, the big convoys, 1,300 megawatt power plants took 5.5 years to produce. There's no doubt you can produce them.
This is central to the whole argument, I think.
The economy of those nuclear power plants is absolutely and clearly established in those countries. And nobody in any of those countries suggests they're going to build nuclear plants to replace all coal, or all fossil fuel, we should say, all fossil fuel. In Japan, they're reckoning on 2020, 60% of their electricity from nuclear power plants, and they are building to that program. In Germany, they're similarly got...
All right, let's just let's see what Dr. KEEPIN says to that, because I think this is central to the argument, isn't it? Whether nuclear is, in fact, a realistic economic alternative.
Not based on some bad American practices.
Well, let's just talk briefly about the American case. The United States does have the largest nuclear program in the world. And in the United States today, it turns out that nuclear power is about 7 times more expensive than saving electricity in terms of displacing carbon dioxide. What that comes down to in simple terms is that for every $100 invested in new nuclear power in the United States today, 1 ton of carbon is released to the atmosphere that could have been avoided had that $100 been spent on saving energy instead.
All right, just, yes, over there.
Look, these are spurious figures, surely, Bill. I mean, there's a lot in that analysis which is very valuable and of great interest. But the UK House of Commons Energy Committee really went into that in some detail in April and called some of those figures highly misleading and false. And it seems to me that you're comparing your marginal cost of energy efficiency, and I agree that there's a lot of upside in energy efficiency, but you're comparing that with your total nuclear cost. But the real question in front of us tonight, it seems to me, is the question of what does a person do, what does a power utility do, what does a state government do when it is confronted with the need to replace old, worn-out baseload equipment. Does it, or to build new capacity if that's needed, if your energy efficiency things don't really deliver the goods to the extent we all hope. What do they do? Do they build nuclear? Do they build coal? And really, in many parts of the world, the whole greenhouse question has pushed that argument very strongly in the direction of building nuclear rather than coal, although it's always going to be a question of both and.
Yes, as you say, it becomes an issue when some government somewhere in the world has to replace a burnt-out old power station. What are they going to do in the best interest of the environment and of energy efficiency? Barry Lloyd.
Everybody's arguing about the use of energy efficiency. I mean, it's motherhood. We all believe in it. What we're really saying is that when you're going to have some power, then let's look at all the considerations which that power is going to need. You need to look at the whole concept. It isn't just the whole question of the cost of the power, it's the cost of the infrastructure goes with it. You've got to compare the movement of fuels coming into a nuclear power station with the movement of coal going into a coal station, or of oil going to an oil station. When you look at that whole massive arrangement, then quite clearly and quite unquestionably, you come out very, very strongly on the side of nuclear energy. You've seen it in Japan. You go to Japan, you see these great power stations there. Japan can't take any more coal, just isn't room to put it anywhere. But they are taking great advantage of nuclear energy. And there are great benefits coming from it.
The immediate public response you get when you suggest a nuclear power station, I'm surprised it hasn't been mentioned yet in the discussion, is the hazards. My God, yes, but not in our backyard. Yes, someone up the back wants to make a point.
Yes, I want to go back to the very first assumption that was made by Peter McGauran and Derek HAMPSON, and that's that nuclear power is clean. I just don't know how people can say that nuclear power is clean when you think of the waste problem that remains after the electricity has been produced. There's still no known way of looking after the radioactive waste, and it remains radioactive for hundreds of thousands of years. And just because you can't see it, you can't smell it, and you can't feel it, it doesn't mean that it's clean.
It's absurd to say the greenhouse effect is bad, coal is bad, therefore let's go nuclear. It's like two wrongs make a right. I mean, it's like treating someone with syphilis by saying, here, have gonorrhea instead. It's ridiculous. What the nuclear industry is doing is producing huge amounts of highly toxic waste substances, which are dangerous to all human beings, and the more we produce, the more dangerous it gets. And the extraordinary thing, I find it quite amazing that the nuclear industry can continue to project the nuclear energy as a good thing in the face of the Australian public's response to substances like dioxin. I mean, plutonium, strontium, cesium, radon, all of these things are at least as nasty as dioxin. There's no way the Australian public is going to wear it.
I think there's a couple of misconceptions that this gentleman's put up. First of all, about huge amounts. The nuclear power industry actually puts out a lot less waste material than virtually any other source of electricity currently, at least the coal-fired one. There's a big difference between a hazard and controlling nuclear waste. The nuclear power industry has a much better understanding than virtually any other industry today on how to handle its waste material. There is no technical problem in handling nuclear waste. The only issue is that people have not yet decided where they want to put them. And that's the bottom line.
Mr. Stewart on my right here pleaded for us to look at examples in the real world, and he cited Japan and Germany. I'd like to ask him if he thinks the example that was announced a couple of weeks ago and reported in the press in Bavaria, where they finally decided to close down a half-built reprocessing factory for uranium, and what they've decided to do is to turn the factory over to the production of solar cells. And that's not just by some tin pot organisation, that's by Siemens, a multinational corporation. Now, if that's not putting your money where your mouth is, I don't know what is.
The simple facts, and you ought to have the truth, is there is sufficient reprocessing capacity in France and Britain. And the Germans have very sensibly got together with France and Britain and said, we will all work together, as they're working together on breeders and all the other things, we will all work together. And the British and French have agreements now with Germany because they do not need that capacity that the Germans were building at Wackersdorf.
Just hold on a sec, please. We're talking about waste and the hazards involved in waste. We've got a doctor sitting beside you, and I'd just like to hear what he has to say about
Dr. Michael Axtons. I have a vested interest in this subject because I'm talking about human health. That disc that was used at the beginning of the program could kill everybody on the Earth because of its toxicity. The toxicity of plutonium, 0.049 micrograms, less than a millionth of a gram, is the dose to cause a lung cancer if inhaled. That substance was not known before 1945 on the Earth, except in one place in South Africa where there had been a spontaneous nuclear reaction many years ago and it was in a stable amount.
Derek Hampson, do you want to...
Extremely toxic.
Kill the whole of the Earth.
No,
that little saucer you showed me.
Could blow us to kingdom come.
Blow us to kingdom come.
I certainly don't want to, but I would far rather swallow a milligram of plutonium than a milligram of cyanide. a milligram of cyanide.
Gonorrhea or syphilis? Gonorrhea, just a moment.
Not when it's injected.
Okay, there is just one thing I would like to clarify for my own benefit here, because I think it's I mean we could argue for a long time about the question of hazards and how we can cope with those hazards. The question I think that is going to influence most governments, and we now have the opposition in Australia looking seriously at nuclear power as an option, is it going to be economic? Can we replace, should we, on straight economic terms...
Health economic.
Should we, let's just leave out the health questions for a moment. Should we, on straight economic terms, be looking at nuclear as the most viable option? Would someone... Yes, somebody at the back, would you comment?
Well, just on the economic question, the point was made before that decommissioning nuclear power plants and waste disposal all carries a cost, but this has all been brought into nuclear economics and makes it competitive. That is simply nonsense. There has not been nearly enough provision made for the fact that once a nuclear power plant reaches the end of its life, it has to be dismantled. Now, in Britain, what they're saying is, for heaven's sake, we don't know what to do with it. We'll leave them there standing for 130 years and let some other generation bear the cost. Now, that looks like a very small cost today, but it's an enormous cost to that future generation that has not had any of the benefits of the power, and I think that's crucial to the arguments about economics.
Well, look, just perhaps a final comment from Bill KEEPIN on this, because it is central to the argument. It's certainly central to the decisions that governments make, isn't it? If it's going to cost a lot of money, they're not going to do it, no matter what it does to the environment.
That's basically right. In the United States, nuclear died because of its unviable economics. In Britain, it's about to die. It turns out it's 5 times, everybody laughs, but actually electricity in Britain was recently privatized. Nuclear industry is scared to death. It's about 5 times cheaper to save energy than to make it with nuclear electricity in Britain. That's widely understood. The economics of nuclear is enough to sink it alone. Frankly, if you level the playing field, eliminate the subsidies, nuclear will sink of its own economic unviability.
Look, I'd like to perhaps just take a final comment on this particular area of the discussion from Jack Walker, because he's been in Europe recently looking at the power industry. He I think, has to take a middle position on this. So just give us the facts, Jack.
Well, I do, and I think that some of the arguments here are a bit fallacious and don't bear fact at all. I mean to say we have Britain that's virtually committing itself to 4,000 megawatt PWR reactors, and they've already started to build one already at Sizewell. Hinkley Point will be next. On the waste issue raised, Australia itself has devised its own waste method by Professor Ringwood in conjunction with the ANSTO at Lucas Heights and the ANU. We are developing the SYNROC process. It's an improved method of the French glass technology. This is a second-generation system, and here are some here. Non-radioactive, I hasten to add.
It leaks cesium.
It does not leak cesium.
It leaks cesium.
And
has it been used for
the point of what
plutonium
these people are saying, and their rudeness, I would point out that our laboratory tests have shown this to be a superb product, and we at the present time are virtually halfway through a program to prove that we can manufacture the product in a commercial scale.
So, can I just clarify this point, because I think it is very important. Are you saying, then, that you're reasonably convinced on the basis of what you've seen from your travels worldwide, that Australia certainly could cope with the problem of waste, and that it is economic also?
Yes, there are reasons in some places where you shouldn't build nuclear plants, and the point was made earlier that there should be a mix of energies in the future, and countries from countries that mix will change. But certainly we should desire to reduce the emission of carbon dioxide and the other hazardous oxides. Nobody would argue with that.
Yes.
But we should carefully develop all those technologies. And I've yet to see and know of anywhere where there's a baseload solar technology plant running anywhere in the world where we have a proven record of some now 430-odd reactors running around the world, producing something in excess of about 400,000 megawatts of electrical power.
All right, you were trying to make a point?
The point I was just trying to make is, if it's a clean technology, as the gentleman on my left have been trying to claim, why are there certain places you cannot build nuclear power stations? Would it have something to do with childhood leukemia rates, perhaps?
Yeah, I mean, that's the whole gist of the matter, really. I mean, the nuclear industry is claiming that it's clean, and yet they're producing a technology called SYNROC, which is supposed to keep highly toxic substances safe for at least 1,000 years. I mean, why do they have to do that if it has to be safe for 1,000 years? We're talking about childhood leukemias, we're talking about solid cancers, we're talking about congenital malformations. It's absurd. I mean, what is going on, I think, really, is that the nuclear proponents are keeping Australia in the dark ages of science, really. What we need to be looking at is creative and imaginative, productive ways of looking at sustainable energy resources, not keeping us back in technologies which are Neanderthal.
All right, just one final brief comment on this.
The nuclear industry is not saying it is clean. It is saying it is cleaner than the options. And the point that I wanted to make...
You said it was clean earlier on, Derek.
I said it was cleaner. The point that I wanted to make earlier on, and which I got chopped off on when I talked about milligrams of cyanide, is that there are people walking around today who have had burdens of plutonium in their lungs way above the permitted levels, and they are not showing signs of ill health. You may get a cancer, but to say that these people have had it for 50 years in some cases, to say that an orange, as some people have said, of plutonium is enough to give every person a cancer in the world is like looking at an Olympic swimming pool with, say, 100,000 gallons of water in it and saying that that's capable of killing 100,000 people because you only need a gallon of water in your lungs to drown. It is a ridiculous analogy.
Well, look, especially we should spend some time looking at another alternative that doesn't involve any health hazards. At least I haven't heard anyone anywhere in the world producing a health hazard associated with solar power. Now, why isn't solar being discussed as a realistic option?
It mightn't constitute a health hazard, but solar power, if it was taken to its logical extension, constitutes a wealth hazard for the gentlemen who are proposing nuclear power, because it's all basically, the question was raised earlier this evening, that what happens when a public utility decides to do this, and what happens here? The question that we're really discussing here tonight is what sort of world do we want to create, and what sort of future do we want to A, inherit, and B, pass on? And a solar energy and a sustainable and a renewable energy-based future would question and challenge a hard energy path. And there's so many vested interests. Solar has never been given a fair chance. Renewable energies have never been given a fair chance. As Bill Keevan said, if you took the subsidies, the props and the delusions and scams away from the nuclear industry, it would fall.
All right, well, David Mills, you're deeply involved in research on solar energy. Why hasn't solar energy been looked at more realistically as a serious alternative?
Well, it is a young technology, and I think it must be recognised that the technology has only been funded in any sense since about 1975. And energy technology takes a while to get moving, but the progress has been very, very good, and the systems that we are developing are very simple. I mean, capable of rapid development. Now, I find it amusing that everyone considers, or certain people here consider that this is a balanced treatment to look at perhaps coal and nuclear and never mention solar. Yet this is our biggest resource,
yes, but
without a doubt.
We talked about an example before when maybe an instrumentality or a government somewhere has to replace a burnt-out power station. They can't seriously think about replacing it with solar.
Oh, yes, absolutely they can. But what you have to do is look at it as a comprehensive solution. We have a very two-dimensional way of looking at this. We see the white plant on the hill or another kind of plant on the hill with a smokestack. But what we should look at is what people actually use. That is at the end-use level, and that's heat. They need lighting, they need motive power, and when you look at the proportions of what we need, about 40% is heat, and a lot of electricity is used to create heat, so we can replace that either with gas or solar heat. A lot is used for transport, which nuclear at this stage is not being used for. Only 15% in our society, and the proportions are roughly comparable around the world, is used for electricity. So electricity is not the main issue. It is a big issue because of the
major issue.
It's a major issue, but it's not the whole issue. And when you look at a solution, this has to be a comprehensive solution. When there are many sources in renewable energy capable of doing it.
Yeah, all right, Bill Keevan.
The solar technologies have emerged so rapidly, it's very difficult to keep pace with them. The cost has dropped radically. It's expected to drop by another order of magnitude. There was a recent, very sober assessment at Princeton University. They came up with the following 2 or 3 facts. Let me just put this out to you. First of all, they calculated the total land area required to displace all fossil fuels on the entire planet with solar power, and it turned out to be less than 2% of the world's deserts, which is about 3.5% of the land currently committed to agriculture. It's not a huge amount of land, and a lot of that could be on rooftops.
But do we have the technology to do it
yes,
now?
Yes, well, it is emerging rapidly. We have it, but once we expand the volume, the price will drop, as I said, to around the nuclear dream price. Third point. The great lure of nuclear power is that a gram of uranium can produce, if cycled through a fast breeder reactor, 3,800 gigawatt hours of electricity. It now happens that a gram of silicon in solar cells can produce 3,300 gigawatt hours of electricity. That's a comparable amount of energy. And moreover, silicon is 5,000 times more abundant in the Earth's crust than uranium. Solar represents a massive resource. It has been absolutely ignored.
Tell me about some of the problems associated with installing solars. Yes.
Well, it isn't hazardous. I mean, you know, just not very prosaic about it, people actually do fall off roofs. In the manufacturing of the silicon, which is used in making solar cells, which is the same material used in Silicon Valley in California, children have been dying of this stuff getting into the groundwater and going down to San Jose, California, which is a little south of there. Bill's played down the amount of area that solar cells will take. A 1,000 megawatt solar station will take about an area about 4 miles by 10 miles, and that's just the solar panels. But we're not against, the nuclear industry is not against solar energy. If it develops to be cheaper, it will be used. We'll be competing against it, and that's all there is to it.
Just tell me then, if we made a decision to close down all our coal-burning power stations in Australia and replace that electricity generation with solar, what sort of land area would we need to take?
4 by 10 miles for a city about the size of Perth, so you can take about 15 times that.
So you're saying then that a major drawback to it at the moment is the enormous land area that you need
the
to make
enormous
it
capital cost, which that translates into.
Can I say something?
David Mills.
Yes, the exclusion zone around a gas-cooled reactor in Britain is 18 square kilometres. If you took that 18 square kilometres in Australia, you would be producing approximately the same amount of energy, and with photovoltaics or with solar thermal. The point is, a lot of that energy will be developed from roofs because the systems we're talking about are generating energy on the demand side, that is at the consumer level, and therefore the land is not being taken taken from another purpose. So the additional land area is certainly, I don't think, any large amount more than nuclear power.
Jim Smith, look, you're part of an association that represents all the electricity generating instrumentalities in Australia. You know, what are the problems? I mean, clearly you and your colleagues all the time are making these decisions. We need to replace this power station somewhere. Do you ever consider the possibility of installing a solar power station?
Well, I think clearly solar is a good approach in many parts of Australia and indeed many parts of the world right now in terms of small standalone units. The real issue that we and other people have looked at is that with current technology, a very large-scale solar generating station is quite expensive in terms of unit costs. That doesn't say, though, look ahead 10 years and the economics might change quite dramatically. As Bill has been saying, the cost curve has really been coming down and will come down a lot faster as volume increases. And I think that renewables, not just solar, but hydro and wind, do offer good opportunities to be in the energy mix by the end of this century.
Can we perhaps look at something much closer to your specific area of responsibility, because you're chief executive of the SEC in Victoria, aren't you? Sure. Now you're having to make a decision about building an extra coal-burning power station in the Latrobe Valley in Victoria. Are you considering a solar power station?
No, we're pressing on with that particular project, but at the same time, we are going to press on with a range of other programs of increasing the amount of renewable energy and gas-supplied power, all of which involve a lot less, or none in the case of renewables, carbon dioxide. And we are also going to have a much more aggressive approach to energy conservation, which is a subject I hope we spend some time on.
We'll come into that next. Peter McGauran, what consideration are you giving to solar in formulating your policy?
Well, naturally, I welcome it. The practicalities have yet to be demonstrated, but that's not to say that there shouldn't be further research, and I'm glad Jim Smith and the SEC is considering renewable forms of energy, but he is prevented by legislation, the 1983 Act, Nuclear Prohibition Act, which the present Labor government brought in, from considering the nuclear option. And that essentially summarises what's wrong with the debate in this country, that it has become a matter of sloganism and ideology.
Yes, Philip TOYNE.
There's no way that I'm prepared to settle on this debate being simply costed out on the basis of the unit cost of electricity, the profit margins available to power utilities in the country. There is a bigger issue at stake here, and that is what is going to represent the best well-being of the community at large. And the fact of the matter is that we can't continue to consume fossil fuels as if they're totally renewable, knowing that they're contributing a major problem to us globally in greenhouse.
So we have to have an alternative.
We cannot go to nuclear when there are so many outstanding unresolved problems in relation to nuclear. It is a violently hostile technology, and we can't accept it. But the reality is that we must bear the cost as a society for looking at those technologies that are going to preserve our existence on this earth, and we're not doing it because we're simply looking at profit and loss equations.
But I get the impression from what you're all saying to me that solar is not practical now. I mean, here we have Jim Smith, who's making decisions about a major new power station, and he cannot consider solar because he cannot yet erect a solar power station.
Solar isn't economic for people in some areas of Australia. It clearly is. And you fly over Australia, you move around in remote areas, places away from the main areas, plenty of solar. What I was saying is that a large solar generating power station at this point in time isn't very close at all.
This is why it's madness to divide up your argument about efficiency and your argument about solar power. The fact is you're going to need a combination of both. And the fact is that solar power can be decentralised as opposed to nuclear power, which can't. You can have individual solar power units spread around. You don't have to have giant power producing units, as Jim's talking about.
Right.
But if you have a nuclear power system, if you invest in a centralised nuclear power system, you're cutting off your options for the future.
Well, what I'm trying to find out is solar a realistic and practical option now, or is it pie in the sky for some time in the future?
If it's not a practical solution now, why aren't we making it a practical solution?
Exactly.
Why aren't we placing that as at the top of our list of social priorities?
What's the funding?
Sorry, have Jessen, and then at the back.
Well,
yes.
I'd like to comment on that. And the reality is that we're putting enormous amounts of money in this country into nuclear research, such as Synrock, which has never been tested with radioactive material over any length of time. And we're putting very, very small resources into our energy research and our alternative research, exactly the same that's happening in the United States. And it's just not good enough, and we need to reverse the cycle and put the money now into energy efficiency and also into renewables.
Right. Jack Walker, would you see any merit in that argument?
I dispute that the Synrock and the comment from the back that it failed. The Synrock has not failed at all. In fact, it's shown to be a superb product in every phase of the operation. There's no difficulty. And further, I would ask Mr. Dr. KEEPIN to nominate where one baseload solar power station is currently operating.
All right.
I don't know if there's any, and you're probably correct, there isn't. But, you know, when you drive down the road, you look at what's coming. You look at that curve coming. We know that solar costs are dropping rapidly. David Mills probably knows that there is a baseload plant. I don't know. Is there a baseload plant?
The photovoltaic plants in California have been operating a long time, except that they have the load during the day when it's required. It's required, but they are very reliable. But you must remember that solar is a multiplicity of sources. It is wind power, it is hydroelectricity, it is biomass, it is all these other things. If you have a solar hot water heater on your house, that is equivalent to negating baseload electricity use, because it is generating power which otherwise would have to generate by electricity.
Okay, one of these gentlemen here.
Could I just say that there is a renewable energy which is currently being developed in Victoria, and that is landfill gas energy, which is part of Jim Smith's renewable energy
Yes, now tell us about
incentive
this. This
scheme.
is a fascinating project.
Well, currently in the City of Sunshine, there's a project being designed to generate about 7.5 megawatts of power from gas escaping from a landfill. And the beauty about this form of energy is that it is renewable because garbage is constantly being generated.
How big is the equipment required to harness it?
To harness it? Well, it uses conventional reciprocating or gas turbine generators. The gas is collected from the landfill and pumped to the generators, and it's used as an alternative fuel. The technology to change the fuel into electricity is conventional, but the fuel source isn't.
Okay, so look, one last point on this.
Just one last point. I'm delighted to hear that the ACF is so enthusiastic about solar power. I hope when the time comes when we're covering Australia with large areas of solar panels and photovoltaic cells, that they will be out there supporting it for all they're worth. And getting pumped storages in order to provide for that electricity when unfortunately the sun stops shining at night, I hope they'll also be there then and not stopping the areas of land being cleared in order to enable this to happen.
Yes, you see, this is the problem, I think. The projections are that the world is going to need 40% more energy in the next 20 years, that the population of the world is going to double in the next 40 years. We're talking about a massive increase in demand, are we not?
Well, this is the absolute critical point, is that we can have a fossil-free, nuclear-free future quite easily if we invest first in plugging the leaks in our system, which are egregious at this point, and secondly in renewables.
This gets us to the option that you've been trying very hard to sell, that if we can save on the energy that we use, we can then produce enough solar power conceivably to meet our demands. Just tell us about this light and how that works. I mean, how much electricity is that saving now and why?
This light bulb here is saving 45 watts as it's burning at this moment. It turns out that if we put such lighting improvements throughout the United States, as an example, we could save $38 billion a year and close down 60 to 70 large power plants.
If you simply install those globes?
This type of lighting improvement, that is correct. And people sometimes find this hard to believe, but I ask you to consider a 20 mile per gallon car with a leak in the gas tank so large that it only got 5 miles per gallon.
Just
now,
explain,
is it really...
can you explain briefly how that works? I mean, it's basically a low voltage globe, is it?
Well, it's a state-of-the-art fluorescent light bulb with a high-frequency ballast that basically has, and it has several phosphors in here that emit colors, so the light quality is very similar to that of an incandescent, a normal light. And the high frequency means it does not have the stroboscopic effect that bothers many people about fluorescent lights.
So you've got intensity,
You've got intensity
of light.
And you've got a warm,
with very low electricity
light.
consumption.
With very low electricity consumption, that is correct. And there are a whole range of such technologies that are available that can basically reduce energy consumption throughout the world. In the United States, it was recently shown that if all such technologies were used, the United States could reduce its energy consumption by half and save $220 billion a year. Which brings me to another point. People usually think that environmental protection and economic development are mutually exclusive goals, and in fact we have the opportunity to achieve both simultaneously, to save money, i.e. help the economy, and to protect the environment, i.e. reduce emissions, in one fell move.
Yeah, I'm going to say to you, when you start saying to people, look, you must start using less electricity, you must start using less power, you're virtually asking people to go back to candles and hair shirts, aren't you? And you're not going to do that in the modern world.
I'm
you get some people
absolutely
to
not doing that. Take a look at this light. It's just as bright as a 60-watt bulb, but it uses 1/4 of the electricity. The truth is, the rooms will be just as warm, the light's just as bright, and the beer's just as cold, and we can achieve all of that with substantially less energy and therefore substantially less pollution.
Simply by applying technology to our apparatus and products that use electricity.
That's absolutely right. Look at it. Look at an incandescent light bulb. You can look at it and you can see it's nothing but a short circuit in a vacuum. It's a relic technologically. All of our emphasis is put on ever fancier supplies of energy like nuclear power and all these other things, and we've ignored how we use it. Somebody finally decided to see what high tech could do to the light bulb, and turns out they could improve it by a factor of 4.
Philip Toyne.
That should be a very optimistic scenario. What casts gloom over it, especially in the case, say, of the privatised power industries in the United States and Britain, is the fact that those utilities have got a vested interest in generating more power. They want to generate more demand. They want to increase demand. That's where their profit lies. And that my concern is that we as a society, in Australia in this case, ought to be able to exercise some control over what is happening in our national interest when it comes to the environment. And that means very, very strong intervention on the part of government. And I think that we've got to be developing a national strategy for energy conservation
What, you
in
mean
Australia.
actually going so far as to say, ban conventional light globes, these are the only sort of globes that can be sold?
Certainly in an extreme situation, that would be a perfectly valid means of addressing a global crisis, which would require us to go onto a war footing. I mean, that's the reality.
I'm just wondering, Peter McGauran, is that a realistic sort of possibility, do you think? Politically realistic?
Well, obviously people have more concern about the environment ever before, and that gives a government more courage to face up to these problems. But that's to be welcomed, Bill. But as a legislator, I'd be interested to know is just how long is this going to take, following on from the comments just made. Is it fantasy land to say that this can be done overnight? And what about the power needed for industry?
It's been done already in Tennessee. The state of Tennessee was set up under the Carter government. The Tennessee Valley Authority was given the funds to run an energy conservation and alternative energy interest-free loans. for example, for setting up slow combustion heaters, solar panels. They're expensive to set up, but they're fairly cheap to run after that. The cost after it was set up in 1979, the cost until 1986 had run into $171 million, and it had offset the cost of approximately $761 million, which would have been ploughed into putting new energy-burning facilities such as a fossil-fired power station up.
DENI Green, you've just done a special study for New South Wales, haven't you, to look at how energy might be saved without any loss of living standard there. What did you find?
I found there was a broad range of opportunities. All sorts of appliances can be more efficient, and some of the things that we can do are very, very low technology. All new houses should be insulated. All new buildings should be built properly. If we don't do it now, those buildings are going to be around for 50 or 70 years using more energy than they otherwise might.
I was particularly interested in what you found with the shower roses, the nozzle on the shower.
There are low-flow shower heads around which use half the water.
Yeah. I mean, what's that like, a low-flow shower head?
You won't know the difference when you use it. There were old-fashioned ones that felt terrible. The new ones feel exactly the same as the current, an ordinary one, but they use less than half the water.
So if every house had one of these...
If every house had one of those, I think we could save about 1 million tonnes of carbon dioxide in Australia.
That's quite extraordinary. So then are we being realistic when we talk about being able to close down maybe half the coal-burning power stations in Australia if we were able to have an efficient, well-organised energy conservation program?
I think we are. Let me give you another example. A recent study in the United States showed it costs no more to build an efficient office building than an inefficient one. And yet if we adopt these efficient building practices today, then in 50 years' time we will avoid the construction of 85 power plants and the equivalent of 2 Alaskan oil pipelines. Now, what I'd like to draw your attention to, since I've been here, I've noticed in Melbourne and Sydney there's buildings going up all over the place, large office building construction. This clearly, to me, represents a golden opportunity for Australia to do it right, to do it efficiently. Because remember, if you build an inefficient building, it sits there and wastes energy and contributes to pollution for half a century.
Jack Walker, is this all realistic stuff we're hearing here?
I was fascinated by the light, and I think it's a great thing. I just would like to ask Dr. KEEPIN, what is the energy investment into manufacturing it?
This particular light obviously requires investment. I'm glad you asked that.
How much, in other words, how much energy does it take to produce this light?
These lights cost, just let's talk economics because it's reflected in that. These lights cost between $20 and $40 each, and at first people think, oh, well, that's ridiculous. But they save so much electricity that they actually pay for themselves in less than a year in a typical commercial application and in 2 to 3 years in an average household. I'd like to compare that 2 to 3 year payback time with the 15 to 20 year payback time for most supply capacity from almost any source.
I'm talking about energy investment.
How much energy is required to run the machinery that produces those lights? Is that what you're asking?
That's what I'm asking.
I have no idea.
Well, isn't that crucial to the argument?
Well, I don't think it really is, because once you expand the volume, the amount of energy saved, I'm sure will be in far excess of what they're produced.
Yes, gentleman over there.
I'd like to draw attention to the fact that at the price that they are available, have been available here for many years, that the person putting one in has to use it constantly to get his money back. Now, if we're talking about the investment in this thing, is it worth investing in or not? And if we looked at another area that the SEC's problem is, you can go and buy a radiator for these cold nights. It costs about $40, $60 a kilowatt, 2 kilowatt radiator. The SEC is faced with investing thousands of dollars, $1,300 a kilowatt, say, in building the power station to serve it. Now, it's all very well to say, oh, we'll fix that, we'll just ban those, or we'll put a tax on them, whatever. But it's the poor person who gets it in the neck.
Yes.
And that's the same with the lights. How many poor people are going to go and buy the lights?
The committed
the
people will spend...
should buy them,
The committed people will spend $40, you say it costs in Australia. It is available in Australia?
This particular one is not, because it's state-of-the-art, but similar light bulbs are. But I'd just like to mention, the city of Amsterdam is actually providing a lease program and giving these to its customers. Southern California Edison, an electric utility, gave away 500,000 of these and generated an effective 8 megawatts capacity for under 2 cents a kilowatt hour instead of building a new power plant. So it was actually cheaper to buy them and give them away for nothing than it was to build a new power plant.
Now, I understand that in the United States they've built a new state-of-the-art refrigerator that uses a lot less electricity.
That's correct. They have refrigerators now that use about 15% of the electricity and keep the food just as cold. And it's very straightforward design improvements like moving the compressor up under the top of the thing so that it doesn't generate heat and heat the very area you're trying to cool.
So then your broad argument is that if we conserve properly, we can cut our consumption by half, and then our consumption demands can be then met with solar power or something absolutely harmless like that.
Yes, as long as you understand conservation doesn't mean doing without. We're talking about providing the same level of service, the same standard of living, using half the energy, and then that half of the energy can be supplied from renewables, and we can have a fossil-free and nuclear-free future.
At the back.
Just one point, not to disagree with anything that's been said, but another way of conserving energy from that light is to switch it off when it's not used and when it's not needed. And there are some behaviour patterns we have to change. No, not to be critical now. But there are some behaviour patterns we have to change without necessarily degrading standard of living. We have to be conscious of the energy implications of everything we do. And it's a decision about whether to take public transport or whether to drive your car, whether to walk to the shops or whether to drive your car. People are using energy for the most unbelievably trivial, unnecessary applications. So there are some things that we will have to do differently. That doesn't mean we'll suffer.
This I think, is obviously a very practical and a very imaginative approach to conserve the energy we're using. But my final question is it realistic, given that we know the population of the world is going to double and our energy demands are expected anyway to increase by 40% over the next 20 years? Jim Smith.
Yes, I think it's quite within the realms of possibilities indeed. The evidence is already coming out, I think, from any number of studies that you can make really huge reductions in the use of energy through energy conservation. We've just run a $2 million study to determine the potential in Victoria, and I'm sure it's no different in other parts of Australia, and that indicates through structural changes, that is better appliances, more energy efficient appliances, insulation in homes, as far as ceilings and walls are concerned, as far as the new high-tech lights that are coming onto the market that can be available not just in homes but also in offices and factories. All these, I believe, in our own country offer really huge opportunities if we take a really aggressive approach towards it, and if we do bear in mind that we have to really help people to change their behaviour patterns, to be convinced of the importance of the changes in their own interest.
Just one final comment down here.
There's two points to make. These kind of things have been around since 1978 in the United States. Why have they made such a low penetration of the market, and why can you expect them to be used all of a sudden in a great big hurry? The second thing is, your estimates of the total amount of energy that can be saved by energy efficiency are disputed quite widely by a lot of other people. You are very much on the low end. What if we do need more energy? We don't have the power stations available. We're all going to have blackouts. We're all going to do without the life-giving, the health-giving, the quality of life-giving things that we're used to. Is that what you're asking for if you're wrong? How sure are you?
I'm very sure that the grand strategy will succeed. I'm actually not at the low end. The low end is that we can save 3/4 of all the energy. I have avoided those low estimates to be conservative. And one of the major reasons these have been resisted is because there's a lot of institutional resistance to them. You know, the philosopher Schopenhauer says truth passes through 3 stages. First, it's ridiculed, then it's vehemently opposed, and finally it's accepted as self-evident. Now, in my opinion, we are in the vehement opposition phase for efficiency and the ridicule phase for renewables. But we will get there. And one of the reasons is that one thing we need to do is to help the energy supply companies and the utility companies to realize they can actually benefit from these technologies. They can actually make money. But at this current time, they regard most of these things as threatening. In the United States, most utilities are afraid of these because they see it as a loss of revenue.
Yeah, but Phillips,
okay, look, I'm sorry, I have to wind it up at that point, and it was a good closing statement. I can only say I hope you're right. But once again, of course, it comes down to us. It has to be the consumers that make the decisions. So I suppose the message, if there is one message we take away from the discussion tonight, is that when we're buying electrical products, we have to ask about its energy rating. We have to be prepared to turn out the lights. We have to be prepared to spend a few extra dollars more to buy energy-efficient things like this. And if we do it, hopefully, I think even Jim Smith agrees, we can then plan to close down half the power stations we've got in the country. But there's a more overwhelming reason. We can cut our electricity bills. Until next week, thank you very much, and thank you all from the studio tonight. See you next week. Good night.